Hello everyone, we are Team 3 and this is our replication presentation. Firstly, let's get into the introduction part. Regarding the problem, our group is concerning about the robustness of on-domain question answering system. The intuition of our problem is that during training time, the language model may learn implicit knowledge from the entity presented in the dataset, which might be used in combination with the given passage context at inference time to produce an answer based on that context and the question. So our question is, does the language model really comprehend, or in another word, understand the context passage to produce the answer, or it just relies on the previous learned knowledge? So our idea for the project comes from this paper on the robustness of reading comprehension models to entity renaming. On this paper, the author proposed a method and solution for our problem like this. Firstly, he proposed a method to audit the ODQA system reading comprehension ability in answering question and its robustness against changing facts. Changing facts here means entity renaming. Secondly, the author evaluates the robustness of different models on multiple data sets. And finally, he suggests a continuous training strategy for improving the robustness of the question answering models. Here is the evaluation pipeline. So this is basically the perturbation process for the test data. Uh, Intuitively, the the author he would find a subset of the test data that contains person, organization, or geography location in the answer. And then through a process of perturbation, he will replace every mention of the original name with the substitute name. So, for example, Angeles replaced by Chicago, or Germany replaced by New Zealand, and we have a new perturb test data.
So to improve the robustness of the model, the author using continuous training and with different match language modeling such as vanilla, who was span and entity. So using the training strategy, the author aim to improve the robustness of the model with the name entity. Next, please. And in this paper, as we introduce in the proposal, they use 5 different data sets, such as that is squad, natural questions, hotbot QA, search QA, and trivial QA. And they also use 3 state-of-the-art model, which is Burst, Robusta, and Spark Burst. Next, please. So now I will talk about our replication results. Uh, uh, our approach is based on the paper and the public code from the author, and we conduct replication with the following steps. First, we fine-tune 3 pre-trained model on 5 datasets, and then we re-implement the evaluation pipeline of the paper, and finally, we perform continuous training. Next, please. So during the replication, we get some difficulty. First, the public code meets the file extract also entity, and also it had some wrong implementation. And so we need to re-implement the code based on the description from the paper, and we use the paper result for correct checking. And also the process is very time consuming, not only because of the training and evaluation time, but also the number of model and data set involved the fine tuning. So we had 3 model and 5 data sets, so totally 15 fine tuning process, and also we have 480 evaluation process for model with original and perturbed data set. So it takes many time for manually conduct the experiment. So we decide to automatic the whole process of fine-tuning, perturbation, and evaluation into single Python shell scripts. So this is our experiment setting for this works. Next, please.
For each type of entity names, we define applicable span types. size of the perturbable subsets for different entity types and their union are shown in the left table. And the table to the right is the statistic for data generated from our implementation. As we can see, the numbers are not totally matched because our implementation of missing file in the code base may not be exact as the author original purpose. However, we have done our best to replicate the statistic based on the paper with similar setup. The difference, however, was not significant, and we plan to keep improving our implementation in the next phase to match the statistic from the paper. The EM scores on the original and perturbed test sets are presented in figure 3 of the paper. Based on our implementation, we also conduct similar experiments. We summarize and plot our results similar to the paper. As we can see, the figure from the paper and from our plot show similar results.
So let's take a closer look at our replicate results. So there are three main takeaways that you can see from the plot that I already list on the presentation. So firstly, we can see that the datasets with distant supervision, like search QA and trivial QA, list robustness, as you can see on the graph. So the reason is obvious because datasets that is collected with distant supervision often encounter a problem is that the context passage might not be even related to the question or the answers. So the model has to rely more on the implicit knowledge background that it learns about entities during training time to make an answer. Secondly, the geographical location renaming shows the largest performance drop. This is also easy to understand since in the test set, the number of test samples that contains GPE is in its answer is very small compared to person or organization. So the model's capacity to generalize based on GPE is hindered. And thirdly, we can see that regarding the model, Spanbird is more robust than Roberta or BERT, largely thanks to its span-based mass language model objectives.
Here is the performance comparison of person names of different national origins on Search Create and Trivial Create dataset. To the right is to the left is the table from the paper, and to the right is our replication results. Okay. In the next stage, we plan to improving robustness with continual pre-training and conduct experiments for all 5 datasets instead of 3 as in the paper.
So in this part, I will introduce some exploration direction and also improvement idea for the paper. First, we can explore about the state-of-the-art models like the GPT model family to see whether this model can overcome the issue revealed on the above experiment. Secondly, we can try different models of different languages to see whether the ungeneralization appear in this model. Next, we will do more experiment with the data. First, we will use another data set like SQuAD to see that SQuAD 2.0 to see that whether the previous trained model still remember a lot of background information about entities on the new data set or not. And second, we propose here an improvement idea. The idea is that the problem is caused by the model remember all the background information of entity. So we will try to perturb the training data with the hope to reduce the model reliance on the background information of the entities. So we hope this can improve the evaluation result. Finally, the perturbable span identification of the paper has some limitation. For example, the format of the name and also the database for country, state, and city. So we would like to improve this algorithm to solve the issue raised in the paper. Here's our detailed plan for the last of the semester. And this is the reference we use in this paper. Thank you for listening.